In this presentation, we have talked about D flip-flop. A flip-flop is called a bistable multi-operator since it has two stable states, 1 and 0. The data flip-flop is called D flip-flop. The D flip-flop is a single input clocked RS flip-flop. To understand more about the functioning of D flip-flop, you should be familiar with clocked RS flip-flop. To understand more about the clocked RS flip-flop, we should be familiar with RS flip-flop. This is the truth table of set to reset flip-flop using NAND latch. Suppose both the inputs are 0, we may get not allowed state. Such a condition is not possible. Suppose S input is low and R input is high, we can get reset state, output is 0. If S input is high and R input is low, we can get our set condition. If both the inputs are high, then we may get no change condition. No change means the previous output is maintained. But in the case of clocked RS flip-flop, these two conditions are interchanged. See here, if both the inputs are low, we may get not allowed in our ordinary RS flip-flop. But in the case of clocked RS flip-flop, if both the inputs are low, we may get no change condition. But here, not allowed. If both the inputs are high, we are getting no change condition. That means previous memory is maintained. But here, if both the inputs are high, we can get not allowed stage. So that these two conditions are complemented in the case of clocked RS flip-flop. This is using NAND logic, this is also using NAND logic. Now come to our D flip-flop. Here we are using two inputs, set and reset. Instead of two inputs, we have to use only one input with a clock. See here, the clock pulse plays its vital role. Suppose the clock is low, whatever be the inputs, set and reset inputs, we may get no change condition. That is, previous state is maintained as such. If the clock is high, both the inputs are low, now itself we can get the no change condition. That is, previous state is maintained. Clock is high, S is 0, R is 1, we can get reset state. Clock is high, S is 1, R is 0, then we can get our set condition. If both the inputs are high and the clock is also high, we may get not allowed stage. This is the functioning of clocked RS flip-flop. In the clocked RS flip-flop, we are getting two inputs, S and R. But in D flip-flop, we are having only one input, that is D input. That input is directly given to the S terminal. Then the complement of the D input is given to R terminal with the help of a NOT gate. Now read out this. In clocked RS flip-flop, we need two inputs. One is set information and the other is reset. Furthermore, one input should complement the other. To solve this problem, the D flip-flop was introduced in which only one input is needed. The NOT gate connected to the input terminal inverts the input value and is considered reset information. In the case of our clocked set reset flip-flop, if you see the set and reset inputs, one should be the complement of the other. If S is 0, compulsorily R should be 1. If S is 1, the value of R should be 0. To solve this problem, to avoid this difficulty, instead of giving two inputs, we are giving only one input, and the complement of the input is given to the reset terminal. through a NOT gate. This is a symbol of D flip-flop. This is the truth table. When the clock is low, X stands for don't care condition. Whatever be the value of D input, the output is no change, Qn. Previous state is maintained. Clock is high. If the input given to the D terminal, that is set terminal, is 0, output is 0. This is our reset condition. Clock is high, then D input is 1. That is set input is 1, output is high. Now we can get our set condition. This is the truth table of our D flip-flop. Verify it. Suppose D is 0. This is 0. So S value is 0. Then R input is automatically 1 because we are using a NOT gate here. 0 bar 1. 0 1 leads to the condition of reset state. See here, 0 1 high clock. System is in the reset state. Then verify this condition. Clock is high, D input is 1, the output is 1. That is set condition you can have. D is 1. Automatically the R input is 0 because 1 bar 0. This is a inverter 1. If it comes out of the NOT gate, the output is 0. So R input is 0. 1 0. Set input 1, R input 0. We may get our set condition. Verify this. I clock S1, then R0. We may get our set condition. So in this way, the D flip-flop is functioning. Instead of giving two inputs, set and reset separately, we are using only one input. Then the reset input is taken with the help of a NOT gate. In this way, the D flip-flop is functioning.